Okay, I'm going to, based on the email messages and the questions I've been getting, there's a little bit of confusion on that last connections lab. So I'm going to do a little bit of coding today to, as a hint to get you started on that. And the thing that I want to cover today associated with that connections lab is basically just to give you a little bit of a framework to get you started on that. But let's go ahead and take a quick look at what the connections lab was. So for the lab, you're going to create two program types, a server and a client. The server is going to run the game, maintain the board state, and communicate with the client. So the client is going to connect to the server and get the board state from the server, display it, let the user make a move, and then put that back into, send that message back to the server. The server will then update the board state and then send the message back to the client again. So note that to play that game, you're going to have two clients connected to that server in order to allow that to happen. So in other words, one server, two clients. In other words, it's going to look like this. Here's the server program. These are the same program. It's just running two different instances of it. So you run one, it'll connect. Run the next one, it'll connect. But there's only one server. And in order to do that, then we're going to need to create connection objects. And you'll notice those are represented by these black arrows here. So there are two connection objects. That seems to be where some of the confusion is coming from. That some of you have tried to implement this with just one connection object, but you need to have two. You need to have one connection object that connects client 1 to the server, another connection object that connects client 2 to the server. All right, so looking at the lab sheet, let's go ahead and refresh ourselves on that quickly here. So let me pull that up and switch this over so you can see it. Let's see here. Hold on one second, I'm in the wrong place. Okay, so here's the lab sheet. And looking at that, you'll notice the server program creates a listener, accepts two connections. So there it says two connections from two client programs. And there's been some confusion on that, so we're going to write a little sample program that does that. But the client program is only connecting to the one server. There's only one server that needs to be worried about that we're connecting to. Now the client is going to be the one that's connecting. The server is going to be the one that's the listener. So we have the listener, we have the client. The listener will be the server. It'll have two things that it listens for. The client is just one. Now here's what's going to get displayed. This 1, 2, 3, 4, 5, 6, 7, 8, 9. That's like the board state. The opponent or the player chooses a move. It then puts a value into that position and then goes on and so forth until the game is over. And don't forget there's bonus for that. Now, quickly before we do that, what I want to do today, and I'm going to keep this really short today, is I want to spend a little bit of time writing a little bit of example code. So that example code that we're going to write, let's start with the server. So I'm going to just switch back over and bring up a, here, let me bring up a new window here and then I'll switch over to it. So let me switch over so you can see that. Okay, so here's this new, oops, that's not what I want to do. Here's this new Python window here that I brought up. Let me put it up there. And so this is going to be the server. So I'm just going to put a comment at the top saying that that's the server. And essentially what this is going to be built around is that multi-processing object, or connection object. So we're going to import that. So import multiprocessing.connection. And then we need this to be listening on some address. So what I'm going to do is I'm just going to make a tuple here. And for our purposes for this lab, since I'm just going to be running this on the local machine, I'm just going to listen on the local host. So that means that other programs running on this machine can connect to it. But realistically, if we were writing this to work over the internet, we could use the address of our machine, our server here, that is open to the rest of the internet and have other devices connected. So if you know the IP address of your system, you could put that there. The second part of the address is the port. I'll just use 1234 again, hex 1234, which we've used before. That's the port number. Now, you could put a different port number there. And in fact, as we talked about previously, the port number is kind of like an extension number of the network. So you could pick that, and you could have multiple servers running on one machine at the same time, as long as they're listening on different port numbers. Okay, so we've created the address. The next thing we want to do is this is the server, so we're going to create a listener. So I'm going to call it listener. Listener. And this listener is going to be a connection object. So a connection object.listener. So here, multiprocessing.connection. That's the module that we imported earlier. And then we need this to be a listener. So we say listener. And the way that listener works is we need to pass to it the address we want to listen on, which is that address we just created. And then in here, it's probably a good idea if you're writing your applications to use one of these connection objects to add some sort of authentication. And that needs to be a byte string. And here I'm going to put the authentication key. I'll put the authentication as that. Concurrency rocks. And to make it super secure, we use a capital in there. Here we'll use a couple capitals here. And we'll use a 0 in place of that. But actually, let's just leave it like that. But you'll notice that we have now created, after this line, we will now have a listener object that's created. And that listener object is going to open this port on this address and start waiting for connections to come in. Now, the interesting thing about this is, and this is where some of the confusion seemed to come in, some of you were trying to make multiple listeners. Now, you could do that. But what's interesting is a single listener can actually accept more than one connection, because what happens when the listener accepts a connection, it creates a new connection object to talk through. So the listener kind of can field those requests, but it will create a new connection for each one of those things that connect. So we really only need one listener, but that one listener is going to create multiple connection objects. All right, so let's say we enter our loop now. So this would be our game loop. And I'm just going to do a while true here. And what I'm going to do at the top of this loop, let's print out a message that says we're waiting. We'll just say waiting for connection 1. And now we want to accept a connection. So to accept a connection, we'll say connection 1 equal listener. That's the listener object that's listening on this address and that port. And we'll say .accept. And when that connection when that connection comes in, when a client connects, we accept that connection, and this is returning that connection object. So once that connection object has been returned, we are now ready to connect. Now, I'm going to do one other thing here, and that is I'm going to print out a message that once the connection gets accepted. So if we get here, I'm going to say connection from client 1. And actually, instead of saying client 1, let me print the address of who it was that actually connected here. So there's actually a way to get that, and that is the listener has a attribute, last accepted, that will tell me who the last client that connected was. I'm going to just print that out. Okay, so that's connection 1, but we need 2 connections. If we're going to follow that model we had in the diagram, we now have 1 connection. Let's accept another one. So we'll have another thing here waiting for connection 2. And here, connection 2. We just accept another one. So if we ever make it to after this, we now have both clients connected. We've printed out that those have been connected. And now we're ready to do something. So now and once we're connected to both clients, we can send data on connection 1 or receive data on connection 1. We can send data on connection 2 or receive data on connection 2, because we are at this point, the only way we got to this part of the code is this one's connected, that one's connected. Now we're ready to play the game. And rather than writing the game logic here, I'm going to just send out some simple messages to show you how to send messages. But let's go ahead and do that. So let's say now that we're connected, connection 1. Connection 1 dot. Let's just do a send here. Send. And what I'm going to send is just a string. So you are, let's say, player 1. You are, and let's tell them that player 1 is going to be X. So we'll print that out. And then let's send a message to player 2 on connection 2 and tell them they're player 2 and tell them that they are O. And that's all we're going to do for right now. And in fact, I'm going to, what we would have here instead of this, let me say, and I don't know how many of you have played internet-enabled games or online games, but this is the kind of thing that is really useful. For example, I don't know if anybody's played the game Jackbox, but that's essentially what you do. With your phone, you have the little web-based app that you connect to. It connects to their server. The server says, hey, it's your turn. You'd enter things in. It then shows up on the main server on the screen, on the PC in the case of Jackbox. And then it sends things out to the different clients and so forth to make that game continue, where all of the players are using their mobile devices as kind of the input. And that's kind of what we're doing here with this. So this is the kind of thing you can do with that. But we would have our game loop here. And then after the game loop, we should close the connections. So down here, connection 1.close, connection 2.close. But note that this is oversimplified in that we have this stuff here. Now notice what would happen here is after we close those connections, we'd hit the bottom of this while loop. We'd go back up for waiting for 2 more connections. So the game could get played again. So another client could log in, another one could log in. Once they're logged in and connected, they play the game inside the game loop that would happen right here. Once the game is concluded, we close the connections, go back up and accept 2 more. So this would allow this server to continue getting player 1, getting player 2, have them play the game, close the connections, go back to allowing the game to be played again. All right, now we're just going to send out these messages, you are X and you are O. Now, if I run this right now, let me save this somewhere that makes sense. Let's go. Here, I'll save it in the folder for this class. And let me call this Okay, let's call it connection server .py. All right, so I save that. Now if I run this, you'll notice what will happen. Apparently I already have that socket open, so let me check something here. Okay, so I had that open because I had a student program up that crashed. So let me clear this so you can see what it does in a clear screen here. Okay, so it says waiting for connection 1. Now you notice that it's stuck there waiting. And the reason it's stuck there waiting is because the server blocks on that listener.accept. It's kind of sitting there waiting for a connection to come in. And I don't have a client trying to connect right now, so this will just sit there forever. So I'm going to go ahead and stop that from waiting. I'll just do Control. I'll just close that. All right, so now we have our server done. Now let's make a client. So let me just go up here into the file, new file. And this is going to be our connection client example. And the connection client example is going to be very similar to the server example, except that we need to make it so that it originates the connection rather than acting as a listener. So it's going to be a client object in this case instead of a listener object. But parts of it are going to be the same, so import multiprocessing dot connection. So that part's the same. Address. Now this, in this case, is the address of the machine we're connecting to, which is going to be the one that the server was running on. So there's the address, and the port needs to match. We'll use that same port number we used before on the server. So this and this need to match the one that the server is running on and listening on. And now we're ready to actually perform a connect. So in order to perform the connection, in this case, we're going to, here, let me print out a message that says we're connecting. So we'll just say connecting to server. And now we're ready to make that connection object. Connection equal. And this is where we make this a client because it's the one originating. It's the one doing the connecting. And we need to put the address that we're connecting to. And we also need to put in our authorization key, which if you remember what that was, it was concurrency rocks. I think I had an exclamation mark on there as well. Here, let's go back and look. Concurrency rocks, and that needs to be a byte array. Okay, so after that line there, we will now have a connection object and be connected because this will try to connect. So now I'm going to print out a message that says we're connected. And we'll say we're waiting for data to come in. And now, looking at the server, on the server side, you remember after we connected, what it did is it sent us a message. So in our case, I'm just going to do a receive. So here, message equal connection. That's the name of our connection object, dot receive. So the other end did send. We're going to do receive. So in other words, whatever they sent is going to magically come through to our end. We're going to receive it. And in this case, in the game, we would do something about it. In this case, I'm just going to print it. So we just print the message it was received. And then just to finish this out, I'm just going to close the connection here. but I'm going to wait for them to hit enter. So I'm going to do an input there. And then we're going to close the connection. I guess let's take off the word done here. That's a little bit confusing. All right, so there we have our sample client. It connects, it gets data. Now in your program, after the connection is created, you don't want to connect over and over again. You're going to connect once. So in here, around all of this stuff is where the game loop would be. Up to here, and this would be after the game ends. That's where we'd close everything down. So note that there would be some sort of loop here that's going to get the board state, allow them to make a move, send the move to the other end with a connection.send. And notice that same connection, it's duplex. So the same connection can be used to receive things, can be used to send things. So we're going to, on the server, the thing you got to make sure is on the server, when it does a send, the client does a receive. When the client does a send, the server does a receive. So we need to make sure that we have those matched up like that in order for that to work. Now let's go ahead and run this. Or let's save it. And I'm going to go ahead and, let's say this is going to be connection client. We'll save that. And now let's go ahead and test these. So I'm going to test these by, let me close out of that. And let me add some print statements to the server here. All right, so let's run the server. And there's the server running. Let me put that over here where you can kind of see it off to the side. Make this a little smaller. Okay, so there's the server running on that end. And now let's go ahead and run a client. Oh, I need an equal sign there. All right, so there's the client. All right, now this is running these in the same virtual machine because I'm running them both from idle. So let's, now notice if you get this message, connection refused, the connection cannot be made because the target machine actively refused it. That means that probably the server wasn't running or was listening on a different address, or it could mean that this authentication key did not match from end to end. So let's actually run these from the command line now. So I'm going to run these from the command line. So let me go to the command line. All right, here's the client and the server here. So I'm going to run the server by double-clicking it. So there's the server running. I'll move the server over to the side here so you can see it. And now let's run a client. Let me move this so you can still see the server. You'll notice that as soon as I ran the client, it says the client says, here, let me make this smaller so you can see this client. And I'll organize these like the way they were in the diagram on the slides. So here's client 1 connected. The server accepted that connection, and notice that it says who the connection was from here. One thing you'll notice is the port number it was accepted from is different from the one it was connecting to. And the reason for that is that frees up the listener object to keep handling new connection requests. It makes a new port number for that connection to talk over. The listening one gets established. It stays open for listening. So in other words, we don't want to keep using the listening socket number, the listening port number, for handling subsequent connections. So it spawns it off into a new one, which is why that ends up being a different number. That's also the port number, outgoing port number of the machine. It was used to connect to that, not the incoming one. But now the server's waiting for connection 2. So let's run client connection client again. So here's another one. And now notice that the server got that. It got connection 2. It then closed the connections, complete, and now it's back to waiting for another connection. But these have now completed. This one got X, this one got O. At that point, they would have played out their game right before this connection, but now this is waiting for another connection. So the cool thing is this server now, if I run the clients again, there's client 1. You see that pop up on the server. Oops. Here's client 2. It connects, tells 1 it's X, 1 it's Y, and so forth. Now, last hint, and then we'll be done with what I wanted to cover today. The last hint here is, how do you exchange the board state? And the cool thing about these connection objects is that they can, notice right now I'm sending a string through to the other end. So in the, let me go back to the server code for a second. In the server code, you'll notice that I'm just sending through a string right now. But the cool thing about this is you could send through really any kind of object you wanted to. So for example, you could send this string, but you could also send through the something that indicates the board state. So for example, if I wanted to send through another object after I sent this one, I could have a variable board state that's kind of before the game begins. We'll say board state equal. And I could actually make this something like a list. So here I could say the board state is 1, 2, 3, 4, 5, 6, 7, 8, 9, representing all of the cells of the board. And right now, they just have these numbers in them. And if I wanted to, instead of making those numbers, I could make those strings. So I could replace them with X's and O's later. And notice I could send the board state through to each of these. So I say, hey, you're player X or 1, you're player 2. Now I'm going to send the board state to both of them. Connection 1.send. And here, what am I going to send? Board state. And I'm going to send that board state through to both of them. Now, if I send that, notice I did 2 sends to each of these. Here, let me make this a little clearer, I think, by doing that. Now, if I do that, that means on the receiving end, I need to do 2 receives because I'm doing 2 sends. I have send for that string, a send for the board state. So let's go and do a Control S and save that. And now let's go to the client. And here it received the message and printed that. Now let's receive the board state. And I'm just going to print that too. All right, so let's go and do a Control S on that. So we've saved both of those. Let's close that server. And now let's go back and try rerunning those again. So there's the server. It's up and running, waiting for a connection. Let's move it over here. And now let's connect with the client. Now notice it doesn't get anything yet because we're waiting for both connections to be created. So let's run the other client. And there's the other client. And you'll notice they both received that same board state, just as it was in the other program. That whole list came through exactly as it was. So that's the idea for how you're going to build your thing. You're going to receive that list, print it out in a nice looking board. Maybe you make a function called print board or display board that you pass this into, and it prints those in. They make their move for what cell you want to put it in based on the index number. You then send that move back. That means the server would have to have a receive to receive that message and parse it in some way. And once that's parsed, you update the board state on the server, send it back out to the next player, and so forth. So this gives you an idea. The cool thing about the connection object in Python is that we can just stick arbitrary Python data, strings, lists, dictionaries, whatever kind of thing, as long as it is what's called pickleable, we can send it through to the other end. And it'll come through just as that object. So it's almost like we're sharing objects across this connection, shoving objects through this connection and having them pop out on the other end. In fact, you could make a dictionary that has all of the information, like player name, board state, whose turn it is, player turn. If it's your turn, it matches. So you could put all that into a dictionary or a list, send the whole thing, parse it, and then you know, oh, I'm player this. This is whose turn it is. It's not my turn. I wait, and so forth. But what I would strongly suggest you do is map out who's sending what at what time. So I would draw like a little diagram, like connections happen. This message goes to the player X. This one goes to Y. Then a response comes from player X. We update the board state. If they made an illegal move, then we don't update the board state. We tell them to try again. So draw out like a flow chart of that in order to do that. But this should give you the basis or basic framework if you follow this, and notice how short these programs are. So it's really easy to just put these in. And if you ever make a commercial project that's using this, I'd strongly encourage you to pick a strong authentication key, have that on both ends, because you don't want some garbage traffic or some malicious actor accessing your connection object and interfering with your program in some way and potentially doing something malicious or destructive. So maybe a stronger password than what I put here, a stronger authentication key than what I put here. But keep in mind that those have to match. And if you're getting that actively refused connection, which several of you, I got emails from you saying that, then it's either the authentication key doesn't match or the server isn't really listening anymore. Okay, so that's all I was going to cover today. Let's go back to the presentation just for 1 second here. And looking back at this, we looked at some example code. I would suggest you work on the lab. The lab really, especially if you plan it out rather than trying to hack it together, it's really not that much code and it's really not that difficult. But if you try to hack it up and just start writing code blindly and make a mess of it, then it's going to be confusing. And any of these concurrent programs like this can get very confusing because you're not dealing with just one program. You're dealing with multiple programs. In this case, one server, two clients. They can all be in different places at different times, and keeping them synchronized and making sure that each of them is doing the right thing at the right time requires some planning in order to do that. So don't just start throwing code together. I would plan it out ahead of time. Who says what at what time? What's the response to that? What happens if they make an illegal move? What happens when the game ends? So how do you start the game? How do you propagate the game? How do you close things down when the game is over? Plan out the message protocol, the back and forth for each of those for that. And that will pay dividends in the long run of making this much easier to do. If you just start writing code and sending things and receiving things and it gets confusing, then it's going to be much more difficult. Okay, so that's it for today. Everybody stay safe. and let me know if you have other questions. I'll give you the rest of the day to actually work on this lab. You can get it done today, I promise. It's really not that much code as long as you plan it out. But go and work on that. And next class, we're going to dig into some new things, and then I want to make sure I leave time this semester to do some stuff that's concurrency, but not Python-related concurrency, something that's in other languages. So we'll stop there, and I'll see you guys next time. Let me know if you have questions.